use the linear approximation, the key estimate using linear approximation, and we choose the value A. The problem will not give you what the A gonna be, but you have to pick the one that's is convenient and also um, lead to the small error of approximation from approximation and round to 3 decimal places as needed. And we can check the value by using the calculator for the exact number. The problem doesn't ask you to find the percent error. So what you need is to use the to come up with the appropriate A near the X, and also use the linear approximation pattern as a function at A, the derivative at A, and so forth. All right. For this one, we have the square root of 68. You have many choices. If you pick A, the X gonna be close to A. So that's the condition for this situation. What do you think? What would be, first of all, what would be the function that you think you're gonna use as a function that you can find the derivative? And we call the linearization or the linear approximation. You're gonna need the function at A. You're gonna need the derivative at A, and then multiply by X minus A. So you need A, you need X, you need the F prime at A, or the F at X or F at A as well. So 3 terms. You're gonna need right here. You need A, F at A, and the F prime at A. What would be the function that you're gonna use? That's not many choices for the function. So kind of we're gonna pick the set of the appropriate number and the function, and then form the linear approximation to find the approximate value. Any suggestion for the function we're gonna use? Are you guys there? Oh, there you go. I hear someone. Thank you.
Would the function be square root x?
Okay. Thank you, Jonas. Yeah, whatever you see, that's do not think too much. Try to pick the pattern that is the same. Like kind of select the one that as close as you can, and then put pieces together one at a time. You need a function. So the function is square root x. Actually, you don't have many choices. You see square root, use square root. So the function is square root x. And then if you use the square root x, you're going to approximate the square root 68. That tells you the x going to be 68, right? 68 based on the function form that you use. Square root, the inside is x, so x is 68. That's gonna suggest you what would be the A or the convenient A that is close to 68. What do you think? You can choose any value the A as long as it's is close to the value 68. But the key is try to make it in a convenient way to find it, to find the linear approximation value. Another hint, you have the square root as a function. You're gonna pick the value A that is convenient for you to work on the process, the steps in the process here. And the number must be close to 68, or the hint, you're gonna have to do something involving square root. Look for the square number that's close to 68.
64.
Yes, 64. Thank you, Jonas. So A is 64. 64, 68, they are close numbers. So from the choice A equals 64, keep going with the pattern. So f at A, which is square root of 64, that's the value 8. following by the f prime. The f prime of the derivative of square root x is 1 over 2 square root x. That's what we did in the first example. Or you can do the same as using the power rule to find the derivative. But I write in the form that convenient to compute. And the x equals a is 64. Then the derivative is 1 over 2 times square root 64, which is 2 times 8. Then we get the derivative as 1 over 16. Okay. So then the linearization or the linear approximation function will be in the form of the Lx equals f at 64 plus the f prime at 64 multiplied by x minus 64. The function at 64 is 8. The derivative is 1 over 16 and multiplied by x minus 64. So you get the equation of the line that you're going to use to approximate the square root 64 or the point x equals 64 on the curve y equals square root x. Next, square root 68 is approximately equal to the linear approximation at 68 because the x is 68 equals 8 plus 1 over 16 multiplied by 68 minus 64 and the x here and put in the calculator and get the number out. In the parentheses we have 4 divided by 16 which is 0.25 and then plus 8 you got 8.25. Okay, this is the approximate value and the exact, just to check whether we are in the right direction or not, just find the square root of 68 and should come out is very close to square root 68 is 8.2462 something. So that's pretty good. So that's a close number, 8.25 and 8.246 and so forth. So we complete the test here. We use the linear approximation to estimate this, and it should produce a small number because 64 and 68 are close number, and we round to 3 decimal places as needed. We have just the ending decimal as 25, and you just add another 0. The function of x, what do you think? The cosine is so direct form here. The cosine of x and the derivative going to be negative sine x. How about the point A? If we choose fx is cosine x, that forces us to have x equals 26 degrees. Okay, 26 degrees. 26 degrees. This is degree. Remember, when you compute the value of the trig function, the angle has to be in the radian form, not in the degree form. So we're gonna use the convenient angle that very close to 26 degrees. The one that's close to 26 would be 30 degrees. And then we're gonna change into the, what do you call it, the radian along the way. Okay, so A is 30 degrees, and then change 30 degrees into pi over 6. Pi over 6. So the x equals 26 here. Change it into the radian as 26 degrees multiplied by pi over 180 degrees. So we are going to approximate the cosine of 26 multiplied by pi over 180 degrees by using the linear approximation at 26 times pi over 180 degrees because we need it in the radian form. Radian as the angle. Okay, that's the big picture of it. Now, since a is pi over 6, the function at pi over 6 or the cosine at pi over 6, what would that be? Square root 3 over 2 or the cosine of 30 degrees. And then the derivative, the f prime at pi over 6 or negative sine of pi over 6 or negative 1 over 2. Okay, we got all three pieces that what we need for the linear approximation equation. So the Lx or the linear approximation is from the function at pi over 6 plus the derivative at pi over 6 multiplied by x minus the pi over 6. Okay. The function at pi over 6 is square root 3 over 2 plus the f prime, which is negative 1/2, multiplied by x minus pi over 6. And then we just use it as x equals 26 times pi over 180. So the cosine of 26 degrees is approximately equal to square root 3 over 2 minus 1/2, and the x is 26 times pi over 180. That we put it in the radian form. So 26 pi over 180 minus pi over 6, and should come out as the approximate value of cosine 26. So let's see. 26 divided by 180 and then subtracted by and the cosine of 26. So the approximate is 0.900939198 and so forth. We need 3 decimal places, so it's about 0.901. And the exact, as you put in a calculator, the cosine 26 degrees, if you calculate it in the degree mode, it's 0.8987940 and so forth. So this example, we have the close number 0.901 and 0.89.